All right, in this video, I'm going to give you a hint how to solve the applied problems in chapter section 3.1. Okay, so right here. Okay, so exercise problem in textbook. Okay, problem number 20. Okay, so wait a second. Right there. All right. Okay. All right. So now the problem number 20 says that it is suspected that the high amounts of tannin in mature octaves inhibit the growth of the winter moth, and then the larva that extensively damage this tree in certain years. And then the following table lists the average weight of two samples of the larva at times in the first 28 days after birth. Okay, so then the first sample was the reared on young oak leaves, and the whereas the second sample was reared on mature leaves from the same tree. So, and then here's the okay, so as you can see that here right there, so sample 1 average weight and sample 2 average weight are given, right? The question A, use Lagrange interpolation to approximate the average weight to curve for each sample. So to construct the Lagrange interpolating polynomial, we need to figure out nodes, right? So first we have to extract node, or we can say we have to transform this table to node. Okay, so now see 0, 6.6, 0.6.67 that can be considered as the x node or node, and then the function value at the node, and then 6.17.33 second node, and then its function value. Okay, all right. So what we want to do, we want to fit the curve of sample and this data. Okay, sample 1 average weight. We want to fit the curve of sample 1 average weight, and eventually we want to figure the predict sample 1 average weight and after 28 days. Okay, so let me see. Give me a second. So, oh. Okay, give me a second. There was some the problem in my laptop, so give me a second. Okay. So now, give me a second. Yeah, this is Octave Online right there. Okay. All right. So give me a second right here, and then so now D was what? Now D is 0, 6, and 10, and 13, 17, 20, and 28. And then come on, the 6.67, and then 17.33, and then 42.67, and then 37.33, and then 30.10, and then 29.31, and then 28.74. All right, and the prime. Yeah, so we got this. Oh, yep. D equals, I missed this one. Yep, so here D. And then now, let me see. Use the Lagrange interpolation to approximate the average weight curve for each sample. Yeah, so now, okay. 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 The first one, we need to approximate the exact the graph of the exact curve using the Lagrange interpolating polynomial, right? So now this D is the what has information nodes and each their function value, right? So now we use this one. Excuse me. So now let's see. P is equal to interpolation, interpol, and then D, comma. What's the W? So yeah, so we wanna plot the graph of interpolating polynomial, right? I mean, approximate polynomial using Lagrange interpolating polynomial, right? So this W must be, let's say, lean space, and then 0 to 28, and then maybe 100. Okay, all right, here, and then we plot lean space 0, 28, 100. That's gonna be input x values. Okay, the output is what? P, right? P. So we got this. Okay, so this is the approximate core, the graph of approximate polynomial to the exact solution of the average weight. Okay, but we don't know exact function. We don't know that. Okay, because the data is only given in the problem. So this is the graph of the um, approximate polynomial. Okay, so now let me see the B. Okay, second. All right, so now next one, B. Find an approximate maximum average weight for each sample by determining the maximum of interpolating polynomial. Let me see. Okay. To find the approximate maximum average weight, polynomial. Let's say maximum of the interpolating polynomial. Okay. Let me see. How can I explain this? Yeah, so to do that, we need to write the code calculating derivative of Lagrange interpolating polynomial. So let me yeah, you don't have to, yeah, do not solve the B, okay? So if you already solved B, yeah, that's okay, but yeah, because yeah, we can do by hand, but it's really it's gonna be really tedious. So because I couldn't cover the how to solve the Lagrange, how to find the derivative of Lagrange interpolating polynomial. So you don't have to solve B, okay? So yeah, let me stop here.